Okay, welcome back. Now we're going to start talking about graphs of other trigonometric functions. And we're going to start by talking about the tangent function. Okay, so I've written out some points along the tangent line from negative pi over 2 to positive pi over 2. So notice how when you go at negative pi over 2, it's undefined. And then if you go slightly to the right of that, let's say negative 1.57, you've got this large negative 1,255.8. And then you go to negative 1.5, it drops down or goes up to negative 14.1, right? So a huge difference. And then at negative pi over 4, it goes to 1. And then at 0, it's 0. And then we'll look what happens here. At pi over 4, it's 1. And then at 1.5, it's 14.1, right? And then at 1.57, it's positive 1,255.8. And then I didn't have room, but at pi over 2, it's undefined again. Okay, so now recall that the tangent function is odd. Right? So tangent of negative x is equal to the negative of tangent x. Okay? And so what does it also mean? It means that the graph of tangent is symmetric about the origin. Right? So you can rotate it 180 degrees and you'll get the same graph. Okay? Now you also know that the identity of tangent function. So remember, tangent function, right? So let's write some of this stuff down. Okay? So tangent x is odd, okay, symmetric about origin, right? And the fact that it's odd means what? Negative, or excuse me, let's do f of negative x, right, equals negative f of x, right? So tangent of negative x is equal to the negative of tangent x, right? And what else were we saying? Oh, right, the identity. So tangent, we also know tangent x is equal to sine x over cosine x. Right? And so obviously it's undefined for the values at which cosine x is equal to 0. Okay, so what does this all tell us? Well, it also tells us, if you look at the table, right, what's happening? As tangent gets closer and closer to pi over 2, it's going up to positive infinity. As it gets closer and closer to negative pi over 2, it's going down to negative infinity. And so there are two vertical asymptotes, right? One at each of those 2 points, negative pi over 2 and pi over 2. So also the period of this function obviously is going to be pi, right? Because going from negative pi over 2 to positive pi over 2 is pi. So the period is pi. All right, so that's some more information that we have. Okay. Also, given the fact that the period is pi and that there are vertical asymptotes at like every pi over 2, right? So pi over 2 and negative pi over 2. There's no, obviously, crosses at the origin, right? It crosses the x-axis at the origin. let's see. So the domain of the function, here's the thing, because of the tangent line, the domain of the function is going to be the set of all real numbers other than where the asymptotes occur. So where do the asymptotes occur? Well, they are going to occur at every x value where x equals let's start at pi over 2. So x equals pi over 2, right? So there's one asymptote. And then it's going to happen at every period, which every period is pi, right? So every period, so this is going to be plus n times pi. And the range is going to be the set of all real numbers. So what is this going to look like? Well, let's graph it. So let's do a graph. So here's the x and y axis, right? And so let's do some tick marks here. All right, and we'll do pi over 2. Yeah. Oh, wait a minute. Pi over 2 pi, oh no. Let's try this again. Pi 2 pi okay, so we got pi over 2 pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and we can do the same thing over here. Negative pi over 2, negative pi, negative 3 pi over 2. Okay, so now we know we've got asymptotes here. So at every pi, right? Like so. And so we know it's going to cross here, 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 right? And so we know it goes from negative infinity to positive infinity, but it has kind of it decreases and increases differently, right? So here it's undefined, right? So that's where the asymptote is. Here it's really large, right? And then you go a little bit further and it jumps up to negative 14.1, and then from negative 14.1 from here to here, right? So it doesn't jump as much. So it's kind of slowing down, if you will. So the way that it's going to work, oh, and then it does the same thing over here. So it's going to do something like this. So it goes up very quickly, right? And then it slows down, and then it crosses, and then it goes up, right? And so it's going to do the same thing. So it's going to go up, cross, and then up. And then it's going to go up again. Like so. Something like that. Of course, don't judge my artistic skill, but that's the way it's going to look. And that is the tangent function. Okay? Now, sketching the tangent function is the same as similar to tangent the other functions, and I'll go through that in the next video.